Who was the woman who discovered how to measure the universe? Henrietta Swan Leavitt is the topic of today's video, so let's dive in. Warning: brutal mispronunciation ahead. Henrietta Swan Leavitt was born July 4th, 1868 in Lancaster, Massachusetts, to Henrietta Swan Kendrick and George Waswell Leavitt, who was a Congregational church minister. Leavitt was the first of 7 children, 2 of which died in their adolescence. When she was 18, she made the choice to attend Oberlin College. However, this decision would not be permanent, as she would transfer to Harvard Society for the Collegiate Instruction of Women, now known as Radcliffe College, after her second year
This is
at
where
Oberlin.
she would complete her degree
In 1892, studying numerous different topics including Latin, Greek, the fine arts, philosophy, analytical geometry, and differential calculus. Leavitt didn't even end up taking an astronomy course until her final year, where she excelled. It sparked an interest that would follow her after her graduation. Leavitt, following her newfound interest in astronomy, would begin volunteering at the Harvard Observatory. Here, she would receive no pay and would work under Edward Pickering. Pickering had a strange philosophy about his workplace. He hired strictly women for the job of computer, who were often way overqualified for the role. They would exclusively take note and record data. They received 25 cents on the hour for their work, half of what a man would have been paid at the time. The work was long and strenuous. Women were restricted from doing anything outside of the role of computer, and even were barred from using the telescopes. Due to the sheer number of women working under Pickering, they would be given the moniker Pickering's Harem, an extremely classy name, and showing how women were seen at the time. A colleague of Leavitt, Cecilia Payne, was quoted saying, "Pickering chose his staff to work, not to think, a very strange precedent to be set for scientists." Cecilia Payne would notably go on to make the discovery that stars were made up of largely helium and hydrogen. Leavitt would go on to leave the observatory, electing to instead travel to Europe and then back to the US. Once returned, Leavitt would have a stint teaching art at Beloit College. Whilst on her travels, Leavitt would go progressively deaf, something that would majorly impact the rest of her life. Leavitt would eventually decide she longed to return to the observatory and would write a letter to Pickering requesting she be granted a return. Pickering, in return, would offer her a job at the observatory, which Leavitt would accept. Now back, Pickering would assign her to study photographic plates, where she worked to measure and catalog the brightness of stars as they appeared on the observatory plates. Her work would focus on the Cepheid variable stars. These Cepheid variable stars differed from others as they made periods of variations, meaning we could track a cycle of these stars' luminosity. This is what would lead Leavitt to her groundbreaking discovery. Whilst studying the Cepheid variable stars of the small and large Magellanic clouds, she would uncover a pattern amongst them. She noticed the star's period of variation directly correlated to the intrinsic brightness of the star. If you can measure the star's variability by taking note of a star's peak luminosity when tracking how long it would take to return to the peak brightness, you'd be able to accurately predict the intrinsic brightness of the star. From that, she drew brighter stars generally had longer periods of variation. This would come to be known as the period-luminosity relationship. Already making a game-changing discovery, she would come to another conclusion. If you compared its intrinsic brightness to its apparent brightness, you could calculate the distance to the star. This would later be named Leavitt's Law. To do so, you would need to first measure the period of variability of the Cepheid star. Second, determine the apparent magnitude of the Cepheid star. This is the measure of its brightness as observed from Earth. Third, consult a period-luminosity relationship based on Leavitt's law. This relationship provides a correlation between the period of variability and the intrinsic magnitude of the Cepheid star. Fourth, using the apparent magnitude and the period luminosity relationship, find the corresponding intrinsic magnitude of the Cepheid star. 5. Apply the inverse square law of light by comparing the intrinsic magnitude to the apparent magnitude. You can determine the difference in brightness. Finally, using the difference in brightness, calculate the distance to the Cepheid star. The inverse square law of light states that the apparent brightness is inversely proportional to the square of the distance. By knowing the difference in brightness, you can derive the distance. However, it's important to note that additional calculations may need to be made to adjust for ulterior factors. Things like reddening and interstellar dust can skew the number. This is just the core principles of Leavitt's law. It's widely accepted Leavitt really never received the proper credit for her discoveries. Her findings were eventually published by Pickering. However, he made it seem he was actually the one deserving of the credit and only mentioned Leavitt as someone who assisted in preparing. It's not known how Leavitt truly felt about not receiving her praise for what she did. She was described as more reserved and unassuming. At a time where women were rarely given their dues, it was very unlikely anything would have come of her speaking up. Henrietta Swan Leavitt passed away after a battle with cancer on December 12, 1921, in Cambridge, Massachusetts, only 45 miles from her birthplace. She was never truly recognized for what she had accomplished in her lifetime. Her death wasn't only tragic due to her remarkable intelligence, but also who she was as a person. Sloane Bailey, a colleague of hers, wrote, "She had the happy, joyful faculty of appreciating all that was worthy and lovable in others, and was possessed of a nature so full of sunshine that to her all life became beautiful and full of meaning." She was buried in the Leavitt plot next to her family and under a plaque memorializing her and her siblings, Mira and Roswell. A year before her death, she was asked what her occupation was. With pride, she answered, "An astronomer," despite never being awarded the title. In 1925, Swedish mathematician Gösta Miltag Leffler wrote her a letter describing his admiration for her and suggesting that he nominate her for the 1926 Nobel Peace Prize in Physics. Harley Shepley, Pickering's replacement as director at the end of Leavitt's life, wrote back notifying Miltag Leffler of her passing, but that instead he should be nominated for his interpretation of Leavitt's discoveries in his own work. Leavitt was unable to be nominated as the deceased could not be given the award. Throughout her life, Leavitt would have completely determined the magnitude of stars in 108 different areas of the sky. Her North Polar sequence was adopted for the astrographic map of the sky in 1913. She would discover 2,400 variable stars. Her work influenced scientists like Edwin Hubble in his discovery of the Andromeda system, her former boss, Harley Shapley's measuring of the Milky Way, Ejnar Hertzsprung measuring of the parallax of many nearby stars, and an entire future generation of scientific discoveries, all of which she saw little credit for. That being said, this isn't a video meant to make you pity Leavitt. Instead, we should commemorate the intellect of the woman who, despite facing both battles with hearing and sexism, she persevered and painted the sky with brilliance.